In this video, I'm going to go over the notes of 9.5. These go over the logarithm properties and how to use them. So these are the properties that you were given, and these are very similar to the exponential properties. You need to look at the log and the base that you're given, and then see what is happening as an argument. Do you have two things multiplying each other? Do you have two things dividing each other? Or do you have something to the power of something else? These three scenarios are going to happen, and you need to understand that you could rewrite them. So like this one, it's multiplying, and then when you recognize that, you're going to rewrite it as an addition of the logs separately. When the two are dividing, you're going to rewrite that as a subtraction of the two parts. And then the other one is an exponent. You need to rewrite it with the exponent as a coefficient. So 3 examples that we're about to go over, hopefully it makes a little bit more sense. Another thing to remember is these facts. These are just telling you that if you have the same base and argument, it equals 1. Anytime you see that, you could replace the whole thing with a 1. And then you also need to realize that if you have any base with an argument of 1, that could be replaced with the 0. All right, let's go over the examples. This example has log base of 2 of 3 over 7. 3 over 7 is this division right here, which says that you need to rewrite it as a subtraction of the numerator and denominator. So we're going to write log base of 2 numerator minus log base of 2 denominator. And that's it for this one. Just applying the rule. Next example here, we have a 24. 24 is a number that could be broken down into more numbers, which will create this scenario. So we're going to find the factors of 24, which is 6 times 4. 6 times 4 could be broken down into 3 times 2. And then 4 could be broken down into 2 times 2. So you end up recognizing that you have the 2 to times itself 3 times. So we can rewrite this as log base of 2, and then we have a 3 times 2 to the power of 3, because we have 2 times itself 3 times. Now we can see that we have two things multiplying in here, which makes us apply that rule that when you are multiplying two things, you add them separately. So we're going to write log base of 2 of 3, because that's the first one, plus log base of 2 to the third power, because that's the second one. This part is already simplified to the most it can because 3 cannot be factored more. 2 to the third power, however, it tells you that it's something to a power, which means we could rewrite it with the power as the coefficient. So we're going to look at the exponent and put it as a coefficient right there. And then we're going to have this. So then we recognize that these two are exactly the same. And it goes back to this rule of if the base of the argument are the same, it equals 1. So this section could be replaced with the 1. And when you have a coefficient, you're multiplying that coefficient times the log. So now we have 3 times 1 for this section. And 3 times 1 is 3. So we just bring this log down, put a plus in the middle, and we add 3. So that's your answer for letter B. Next, we have another fraction. So that is the rule of quotient property, which we write it separately as subtraction. So natural log of 5x to the 7th power minus natural log of y. 5x to the 7th power means we have 5 times x to the 7th power. So on this one, we do have a multiplication happening. We're going to write the separate as addition. You can always pause this video or rewind if needed. Make sure your goal is to understand what's happening. After you have this, you recognize that this middle one has a power. So we can apply this rule of the power going to be a coefficient in the front. So this, only in this middle part, we're going to have that power go in the front. And that's how it's going to look. So then we bring this down. And that's as much as we can simplify. Next, we have log base of 2 and 8. 8 is going to be a number you could break down. So we have 2 times 4. 4 is 2 times 2. This is a 2 to the power of 3 again. So we're going to write log base of 2, 2 to the power of 3. We recognize that 2 to the 3 power is exponent. So we put it as a coefficient based on this rule. Exponent goes to becoming a coefficient in the front. So exponent of 3. Now it's going to look like this. And then this base and this argument are the same, similar to the top, which means we can rewrite this as a 1. So 3 times 1 is 3. All right, in the next part of the notes, you have it backwards where they give you the expanded notation and you're supposed to apply the rule to make it smaller or more simplified. Here we have an addition of 2 logs, and then if you look at your properties, addition is whenever you multiply the 2 arguments. So we're going to have 9 times 3 multiplying each other, and then 9 times 3 is 27. Next, we have a subtraction, so similar to the process before. We have a subtraction, and then that becomes a division of the numerator and denominator. So numerator of x, denominator of 9. And that's as much as you can simplify that one. All right, the next one is we have 3 sections, and then carefully look at this middle one. This middle one has a coefficient. So we're going to do what we did here, but just backwards. We're going to write this is an exponent, so 2 to the 3rd power. I'm just going to copy everything else. Then you recognize that these are adding. So that means we're going to apply the addition. It's a multiplication of the arguments. So we're going to have 9 times 2 to the 3rd power. And then now you recognize this is a subtraction. So the subtraction is a division of the arguments. So we're going to write 9 times 2 to the 3rd power divided by 3. And we write it as a log. This needs to be simplified because all of it is numbers. You can just simply type it in your calculator or do it by hand. If you do it in the calculator, you will want to type 9 times 2 to the 3rd power divided by 3. Oh, I typed it wrong. And it gives you 24. So this is the same as saying log of 24. All right, last example here is looking at, again, the 3 parts and seeing that this is a coefficient. So that's going to be an exponent of 3. And then we're going to have another addition in the beginning. So this addition becomes a multiplication of your arguments. And then this subtraction becomes a division of the arguments. And then we simplify the arguments. So we're going to have 4 times 3 to the 3rd power divided by 12. And we get 9. So here we have natural log of 9. All right, in the back of this paper, we have a scenario of what do you do when using a scientific calculator that does not allow you to use any other base than 10. So the graphing calculators we have in class, we do have access to typing log with a base. But if you're using a scientific notation, that is not possible to change. It's just log, which means the base is 10. So whenever we want to change that, we want to follow this pattern where whatever base you have right now, and then whatever argument you have right now, they get broken down into like a division of the logs with the new base. So for example, here's log base of 3, argument of 8. We're going to rewrite it as log, and you could just leave it as log because that's what we're talking about, base of 10. The argument is 8, and then the base that you had was 3. So this just simply says that we are rewriting it into a different format. I'm going to show you how log of 3, argument of 8 gives you this decimal. And if I type this, it's going to give me the same. So I'm going to leave the base of the log empty. That way it takes it as a 10. And notice that it's going to give me the same decimal. Which also means in this example right here that if you have a log that was converted the same way, it also could be written as natural log of the argument with the natural log of the base. So just to show you that, I'm going to show you the natural log version of this. And notice it's the same decimal. So this paper is just in the back showing you how you can rewrite any base to the base of 10 or natural log if needed. So for example, this one, just for practice, we're going to have the argument written on the top and the base on the bottom. Whether it's natural log or log. These others, argument is 14, base is 8, and then you just write log or natural log. And that's pretty much it in this notes. You just want to practice using the logs. So I'll leave this one blank. I think by now you should already know what to do. Hope this video helps you.